guys watched the movie? Not me, but have you guys watched the movie? There is a movie if you want to watch it. I'll put it that way. It's under the library, chemistry. It's called Day One. And it's actually supposed to be the most accurate representation of what happened and how the Manhattan Project came into place and how the atomic bomb was developed. You would recognize some folks in it, like the guy that plays Monk is in there, Tony Shalhoub or Anthony Shalhoub, whatever. He plays Fermi, and Fermi was a scientist, an Italian scientist, after which fermium was named. Rutherford is in there, Oppenheimer, of course, Einstein, and it really does show a good representation of how things went down when they're developing the atomic bomb, and how they didn't know what they had. At one point, Oppenheimer, who's considered the father of the atomic bomb, said, oh, you know, we'll see a flash of so many miles, and we'll do this, and I'll do this, and that. And, I mean, he way underestimated. Most of the scientists that were corralled to work on the atomic bomb became pacifists after they saw what happened. And the closing scene of the movie is really kind of poignant to me. They're looking at clips or looking at slides of the results in Hiroshima, and you can see their faces and how they just. I mean, one guy gets up and walks out because he's just sick. So it's normally I have you watch that as a lab, but since we're on a shorter semester, I won't make that a lab assignment. But if you want to watch it, you can live stream it or get it. It's on Netflix too. But it's really, ultimately there was no reason for us to drop the atomic bomb. Japan had already surrendered.
You could say, hey, we built it, might as well use it.
Exactly. We're going to do it to show everybody else that we've got it, is basically why we did it. Japan had already surrendered. Everybody was already, Nazis had already been taken over. Japan had surrendered. There was no reason for us to drop the atomic bomb. They're still having the effects. Now, the bomb was dropped. Anybody know what year it was dropped?
What year?
Yeah.
It was dropped in, wasn't the 60s, if I'm not mistaken?
40.
Because I know people can't go there because of the radioactive.
Now that's Chernobyl was in the 80s.
Okay.
I'm talking about the atomic bomb. It was dropped in like 46. The year my parents got married. Or a year after my parents got married. My parents got married in 1945. They dropped the atomic bomb in 1946, 46, 47, I can't remember exactly when. So, this is not really that long ago, if you look in the big picture. But they're still seeing high levels of birth defects in children born in the area. They're seeing high levels of radiation in the area. And if you've ever gone on, if you want to Google on YouTube, or go on YouTube, and I will show you guys a video from Chernobyl. But if you go on YouTube, you can look at results from Hiroshima and Nagasaki, which are the two places. Yes, we dropped a second one a few days later, again, for no reason. There are images, and that's all that's left of some people. Images on the wall from where the blast and the light was so intense, these people were immediately irradiated, gone, just gone. But they left an inverse shadow on the wall. So the wall is darkened, but you'll see a white outline of a person. And that's the person that was standing there when it happened. The BBC did a really, really good documentary on that, and you can find it on YouTube.
What's the name of that one?
I can't remember what it's called. I'll post them on under the go on this afternoon and post them under the links, under the
Under
resources.
instructional media or whatever that.
Well, I'll put it on Angel under it's resources and then links. Okay. Because it really is, I mean, to me, with the issue right now of energy and power and how are we gonna sate our desire for more and more electricity and not use oil. Well, the second best, most readily available source of energy is nuclear. Now, you know, France uses it all the time, and they say they use it safely, but would we really, we would know, I think, at this point if they had a problem. But the advent of the atomic bomb, the reason I link all this together, the advent of the atomic bomb, the use of the atomic bomb then led to our being able to use nuclear power. Now, Chernobyl in 1986, April 1986, Chernobyl was a Russian nuclear power plant. The economy in Russia was going down the tubes. They didn't have the money to maintain the power plants like they should. They were running a routine maintenance check, or safety check, and there's been speculation from everywhere from the operator was drunk to nobody knows why it happened. But a valve was shut off that allowed cooling water to get to the reactor. The reactor overheated. The reactor blew up. The world didn't know about it until about 3 days later, when they detected high levels of radiation in, I think it was Sweden or Switzerland. We have radiation detectors that the world, different countries all over the world have put up after the dropping of the atomic bomb, because of the widespread nuclear radiation that was carried from that. The radiation from Chernobyl made it as far as Seattle, Washington. I have a friend, a former student, who was living in Germany at the time that the Chernobyl incident happened. She had just had a baby. They had to stay inside for 2 weeks. They couldn't go outside. They were not allowed to go outside. They had to, you know, pull down all their curtains and, you know, tape up the doors and all this stuff.
And even then, were they?
No, even then it wasn't.
That's not enough.
There are areas in Scotland that are still so radioactive that the sheep, when they graze, their levels of radiation are too high to be used as food. Now they use their wool. I wonder if the sweaters glow in the dark. But they can use the wool, but they cannot consume the sheep. And now this was 1986. The areas are still too radioactive. In Chernobyl, they're still not allowing people to come back and live because of the high levels of radiation still. I will show you, to kind of break you in today, in the video of, there was a documentary, a Russian documentarist, guy that made documentaries. And he was allowed to come in to Chernobyl a couple of days after it happened. And he filmed it with the results. There were folks called biorobots who their job was to go up on the roof of the adjoining building and clean out all the graphite. They were only allowed to work for 15 minutes at a time because the radiation was so high that they've been up there longer than 30 minutes. Their bodies actually would have started falling apart. There were, something like 3,600 biorobots that were hired. 10 years later, 2 of them were only one still alive. All of them died from dispersed cancers. This guy, the guy that did the documentary, got home, started getting sick, went to the hospital, died within 3 weeks of dispersed cancers. Now, there has been approval by the government of Georgia to build 2 new reactors in South Georgia. Yes, we've learned from Chernobyl, yes, they've got better safety things, supposedly, but do we really wanna risk that? I mean, the people that were inside of Chernobyl when it happened, when the reaction happened, are overheated, and where else have we just seen all this? Japan. They're seeing the same thing that they saw at Chernobyl in Japan. But because they used ocean water, they used seawater to come in and try to cool the reactor and then pumped it back. They're seeing high levels of radiation in the fish that they're catching now. They're seeing high levels of radiation still in the area of the nuclear power plant. I was actually listening to a report that there were older people in Japan that had retired from that power plant, the nuclear power plant, and volunteered to go in and work on shutting it down to save the young people because they knew they were going to die. I mean, would you be able to make that choice?
Nope.
I mean, they knew they would die from the levels of radiation that they were going to be exposed to. And they went in to save the young people in the village from having to do that, the younger workers. But in Chernobyl, when it happened, the first layer of people closest to the core were just like what happened in Hiroshima, vaporized. There was a second group of people, and they were burned, and their friends, not knowing, tried to go in there and rescue them, which meant they didn't come back out. And they were in there, it took about 3 days, but they just slowly died from radiation poisoning. And it's a very slow, painful death. You're basically being cooked. Like I said, the biorobots, out of 3,200, there were 2 left about 10 years later. Most of the people that responded to the accident at Chernobyl are dead. The fire engines, and you'll see this in the video, 10 years later, the fire engines that they used, the equipment that they used to respond, still the levels are so high with radiation that you can't go near them. And they're just sitting out in the field in this town. The fire engines, the ambulances, the airplanes they used, or the helicopters they used to spread dolomite to try to put the fire out. I mean, all the first responders are dead from that exposure. So, and they don't count those among the victims. They don't count the people that died as responders, or died as biorobots, or died from being in the scene afterwards.
Why would they do that? To keep the numbers artificially low?
Mm-hmm. Yep.
So why is it that we still use radiology technology now?
We think we've got it under control. We think we know what we're doing with it.
See, I say that because that's the field that I'm going into, so I wonder why we still use it.
It's the best thing we've got. It's the best thing we've got. We think we've got it under control. But my point, and why I want you to watch, one of the other reasons I kind of want you to watch this movie, is it is still so new. I mean, it's only been in existence 60 years. We don't really know what it does. We don't really know the consequences. Just like Oppenheimer didn't know when he, pushed, there were 2 schools of thought. There was Szilard and Oppenheimer. Szilard is actually the one that came up with the way of doing the chain reaction to make the nuclear bomb, the atomic bomb. The first place they tried to carry out the reaction was in Chicago, the University of Chicago, under the squash courts. Okay, this is how cocky they were, how confident that they knew what they were doing. And it went safely, but if it hadn't, Chicago would have been blown off the map. But they were so sure about what they were doing, they were willing to take that risk. Well, then they get it out to Los Alamos, get everybody locked into Los Alamos, and working on the project, and the prototype that they dropped, it was 10 times worse than they predicted. So they really didn't know. And that's kind of my point now. We think we know, but do we really? Because they thought they knew. But do we really know? Do we really know that now nuclear power is a safe thing, that we really do want to not only build new ones, but refurbish the old ones that would shut down after Chernobyl happened? Hell, we've had it happen here, 3 Mile Island. We had a nuclear problem there. And they are still seeing high levels of childhood cancer coming in. So it's something that we really need to think about, and yes, this is one of my pet things, being an environmental scientist. There are better ways, there are other ways to do it. And if any, I mean, when you do, I know you're going into radiology, or nuclear medicine.
Neurology.
Yeah.
It deals with, it's a high levels of radiology in there because I'm dealing with the CT machine and the MRI machine. So that's why I asked.
And we think we've got it harnessed and we think we've got it under control. But do we really? And I thought about that. I had to have one of the procedures where they do iodine, and then they send through a contrast, or they do it was an upper GI or something, and they do send in the contrast, and it's radioactive iodine, and you can taste it. The minute it hit, I looked at her, I said, "That's iodine, isn't it?" And the girl kind of looked at me, how'd you know that? Because I know what iodine smells like and what it tastes like, and you can taste it. And I'm sitting there going, I'm not really happy about being able to taste this. And I'm not really happy that you're putting this through me, but okay. How do they adjust the thyroid? Have I told you the story about my friend that had thyroid problems? The guy in the office next to me at the chemical plant? He had thyroid problems. It would oscillate between hyper and hypo. I mean, it was just completely out of control, and he could drop 20 pounds like that. I mean, in a weekend, he could drop 20 pounds. It was the most amazing thing I've ever seen. And then he'd swell up, and then he'd shake, and then he'd sweat. I mean, and they tried different kind of medications, but they finally had to go in and do radiation to kill part of his thyroid. The same kind of radiation they do for cancer treatment, kill part of his thyroid. He couldn't come back to work for 3 weeks. He couldn't be exposed to his family. He had to stay in his room. Now, and this is it. Okay. Radioactive iodine. Let's get into this a little bit. Iodine, if I look at just elemental iodine, all right, what's the symbol for iodine? That's the symbol for iodine. What's its atomic weight? It is 53 and 127. So, 53 and 127. You know something's an isotope, and that's what they shoot you with when they do radioactive. It's an isotope. The symbol will be reversed, so you'll have the atomic number down here, and you'll have the atomic weight. What makes it on top? What makes it an isotope is that you've got a different number of neutrons. Okay, so 127 is normally what it weighs, so say it's 128. It's still iodine, so we know the protons are 53. We know the electrons are 53. But instead of having, what is 127? 74 neutrons, it's got 75. And we indicated as the atomic weight on the bottom, and the atomic number on the bottom and the atomic weight on top. That's how you symbolize an isotope. So, like carbon-14 would be this. It's still carbon, but it's an isotope. Okay. So what happened with him was they had to shoot him his thyroid with radioactive iodine. Radioactive iodine has a half-life of 8 days. What a half-life means is that if I've got 100% iodine at day 0, so he's had radiation, he's got 100% of the allowable level of the radioactive iodine. Well, after 8 days, that drops to 50%. After 8 more days, that drops to 25%. So if, for instance, you had 10 grams, after 8 days you'd have 5. After another 8 days, you'd have 2.5. What happens when you cut something in half? You keep cutting it in half. Does it ever go away?
No.
No. We just think it's at an acceptable level at a certain point. Usually less than 0.3% we consider safe. So this guy goes in, gets radioactive iodine shot into his thyroid to kill off part of it. He goes home. They don't let him out of his room. His family can't be around him. The wife cooks some food, opens up the door, slides a tray and closes the door. Everything that he touches has to be put into a biohazard bag. The plates, the paper plates, the napkins, everything, anything that he uses to eat from, the trays, everything has to be hauled off in a biohazard bag because he is so radioactive. And it took 3 weeks to get it down to a point where he could actually be back to work and considered safe to be exposed to other people. What I want to know is what they did with how they controlled what came out of him. Think about it.
They probably put in biohazard bag.
I hope so.
Probably not.
Probably not, though. Probably went right to the city. They were able to track, I don't know if you guys remember that a couple of years ago, there was a British spy. And he was spying on Russia. And the Russians figured out that he was a spy. So his contact, he flew over from England to Russia. Stuff always happens in Russia, I don't know why. Flies over to Russia. Meets his contact for dinner. His contact puts polonium-210 in his drink. And it's not just, this was really true. Puts polonium-210 in his drink, which is a radioactive isotope. Now, what we mean by radioactive isotope is that it's unstable. So iodine, like this, is not stable. What these isotopes try to do is get rid of the imbalance of neutrons. And they do it a couple of different ways. There's 5 different ways that they can adjust themselves. All right? There's alpha, beta, gamma, electron capture, positron emission. But we'll go over those tomorrow. All right, so they try to adjust themselves, and that's what makes them unstable. When they adjust themselves, though, they can get rid of protons. What happens if I change my number of protons?
You change the atomic number, don't you?
You change your element, because remember, a proton, the number of protons tells you what your element is. So if I decide, if I'm an element and I decide to adjust my level of protons and neutrons by getting rid of a proton or splitting it up into a neutron and electron, I go through what's called transmutation. It's one of my second favorite word next to stoichiometry, transmutation. And I've actually become something else. That's what nuclear chemistry is all based on. That's what the nuclear reactants are based on. You're taking uranium-238, or 235, 238. I know uranium-235, I think it is. Okay, it has a half-life. Anybody want to wager what its half-life is?
You said 235.
3.9 times 10 to the 8th years. Okay, this is what we're using in our nuclear reactors. So, when they talk about the waste that comes out of the nuclear reactors, uranium-235, it gets bombarded with neutrons, it becomes plutonium, I think it is. I can't remember exactly what the reaction is. And then it chain reacts, but then it produces more of its own stuff. And that's what we haul off and bury underground. We used to put it in Yucca Mountain in New Mexico. Poor New Mexico, we just get so surprised we don't have mutants coming out of New Mexico all the time. Between Los Alamos and the fact that they bury all the nuclear waste, or did. Okay, what Yucca Mountain was a big artificial mountain. Well, I don't know if it's completely artificial, but they drilled down and put in this big concrete area, and this is where they hold all the nuclear waste. Okay, do you know of any container that's going to hold something for 3.8? No, it's 4.3 times 10 to the 8th years. That's a lot of years. And if you think about it, half-life, if I've got 10 grams of that, it's going to take that long, 4.3 times 10 to the 9th years, 8th or 9th. And there's only going to be half of it left. There's going to be half of it left. And then half of it.
But why do we put it underground? Why can't all this technology and everything we know about astronomy, why can't we have some kind of indestructible satellite-based landfill in outer space? Because once it starts moving in space, it just continues to move, so can't.
You remember the Challenger?
Is that the one that blew it up?
Do we really want that happening?
I mean,
Because when if we send a ship like that up, the likelihood, I mean, there's less of a likelihood of it escaping from under Yucca Mountain than there would be, unless we have tremendous seismic activity, which could happen. But you shoot it up into space and you go full throttle down. That's right, most of you probably weren't even born when Challenger went off. Full throttle down, boom, and then you've got all this nuclear waste raining down on the country, everywhere, on the world, and trapped in the atmosphere.
Stick to the black hole.
My buddy used to work in the Navy, was on an aircraft carrier, and he'd tell me, man, he was like, he could lose you in about 2 minutes on like the stuff he did and all. It was pretty cool though.
I had a friend
There's
that
like
used-
stuff he couldn't tell me though, it's still like top secret.
Oh
and
yeah?
all.
In the nuclear subs? You never hear about. Yeah. And you guys remember the sub they just had to sacrifice in Russia? I think it was Russia. They had problems on the sub and they couldn't rescue them.
That's my next question. It wasn't my next question until now. But based on science, okay. You know how the 2012 thing, I don't believe in that, but if it were to happen, how come they just can't build a whole bunch of big submarines and we just be underwater when all that happens? And then when it's over, we just come up?
Because if you
Oh,
do that, it goes back to
you just-
different
Second,
like,
No.
second arc?
like
Like the movie.
I don't know. I mean, to certain people,
Because if the
are
wave is
asked
supposed
about
to be
religion.
250 feet high, then why
How
would we
who do you decide who to save and who to not?
We should have
How much
enough
money is
money
that?
to save everybody. Raise taxes by 0.2
No.
2 cents.
You're talking about worldwide, I mean, come on.
I'm not talking about world, I'm talking about America.
Well, now think about it, when I started talking about Chernobyl, I talked about, Russia used to be part of the USSR. And they broke it all apart and left them, the countries, and that's when all the Uzbekistans and Kurdistans and all those countries didn't used to exist. And this has happened within my lifetime. That they broke it all apart, they started off on their own independent economies, and they tried to run their economies the way we do, a free economy. Well, the part that became Russia couldn't function that way. And they're still suffering from it. But I mean, basically what happened was their economy crashed and burned. Does it sound like anybody else you know? And they didn't have the money to keep up the repairs on the nuclear power plants. We don't have the money to do stuff like this. We don't. The U.S. doesn't, I mean, we're barely.
We got it.
I understand. I understand we have money, but exactly who are we indebted to? They always say we're in debt. Who are we indebted to?
All the other countries.
But they broke too, so I
Money
mean.
from the Federal Reserve, and then that's owned all privately by bank holders. You got like 6 people that control all the money for you.
Yeah, but it broke too, so I mean, how can
But if
somebody-
you think about it now,
They loan money to the government on 7% of the dollars, so you're never gonna pay it off.
I just want to be on the
So they can control inflation, they can control war.
of course, with our luck, it'd be a nuclear powered submarine.
Yeah,
The more wars, the more money those banks make.
Oh, no.
I
Okay.
want to show you this video, some of this stuff on YouTube.
I don't know about that on the submarine. Because when I seen when the oil had, when they were drilling, the oil had got on top of the water. Like you said, oil and water don't mix.
Right.
So, and then they was talking about the sun was flaring so bad. I said, well, what if the water catch on fire? Then what we gonna do?
Okay, well, that probably couldn't happen right now, cause you know, oil's gotta be, crude oil, it's gotta be refined to be able to be burned efficiently. Okay. But what is happening is, and I know a lot of people are poo-pooing global warming, but I'm sorry, 109 degrees in Kansas at 6 o'clock at night?
You should see in the veterinary field how many people is coming in because we did not have a winter. It's overflux of ticks, it's overflux of fleas, and all these flea medications is not working.
They're not working.
My dog died. She's been inside all week. She can't
My
stand
cat,
the heat.
my cats, I mean, I just put Frontline on them,
It's not working.
and they still have fleas.
Because there's two reasons. One, they diluted it over time, and two, I mean, you can have the best medication on them, but if it's so many, it's gonna overpower that medication.
Well, where was I going with that? What was I saying?
Global warming.
Global warming, thank you. Part of what's going on is there are large, they're called clathras, and they're like icebergs, but they're made of methane gas that are at the bottom of the ocean. Yeah, you can-
Okay.
And what's happening is, as the oceans warm, not only are we losing our coral reefs, there's a report out this morning from, 30% of our coral reefs have died from the higher temp, and it doesn't take much. I mean, we're not talking 10 degrees that we're talking 2 degrees. 30% of our coral reefs have died. If our coral reefs die, then a lot of our first line food chain have no place to live. Right? So, as the temperatures are warming up, these clathras are starting to melt, and the methane gas will come up. And this is already happening in Antarctica, where they can poke a hole in the ice and light it, and it burns for days.
Now, can we capture that?
If we can capture it, that would be great, but it's kind of hard. I mean, it's so deep in the ocean. And if we can somehow figure out, right now we can capture it because there's still the ice cap or ice areas, and we can drill down but once those start going, in my theory, okay, this is a chapter, yes, this is the depressing chapter. If you have any relevant, I mean, I'm not a particularly religious person, but what was the way in the Bible? What does it say? The next.
He's gonna come back and burn. He's gonna come back with fire. And that's what I was saying because when the oil was on top of the water, and that's what I was thinking. That was first thing.
It ain't gonna be the oil though. It's the methane gas, because it. And it's already happening in Antarctica. They're already seeing this happening. And they don't talk, I mean, you don't hear a lot of talk about that. Everybody's worried about the glaciers melting and the water levels coming up, which is happening as well. I can show you a map, if I can find it. I had it for in one of my environmental classes, of what's going to be underwater if I think it's if half the glaciers melt, or if all the glaciers melt. The ice caps, no, it's the ice cap. If the ice caps melt, New Orleans will be gone.
Of course, it's a toilet bowl. It sits up. It's like a big old bowl.
I know. I was just there. I just came back from there Saturday, and I didn't exactly. I mean, I was eating at a restaurant with my friends, and we were leaving, and my friend was going, okay, and there's the bridge that's going to lead you over to the other part, and there's this big wall. And I didn't realize, but that's one of the walls that they talked about. It's not that wall, but that's like one of the walls that gave away during Katrina and flooded New Orleans. But yeah, most of New York will be gone. California will be gone.
Well,
Maine will be gone.
All on that coastal line.
All the coast areas, anything on the coast will be gone.
So
Will
that
be underwater.
Georgia.
We're probably okay this far in Georgia.
That, like,
But,
for Savannah.
like I said before, yeah, and where I grew up, toast. But we used to be, and actually that all used to be underwater. The ocean used to come up, the shoreline was, they've decided, it was right along Manchester Expressway. So anything south of that was underwater. We are the last area that was the Piedmont. We're right where it fell into the ocean.
That's Manchester Expressway right there, right?
Yeah,
Okay,
yeah.
so
We were
Columbus
okay
Tech
here.
might be,
We were oceanfront property then.
yeah, okay.
But that's why you can go on Fort Benning and you can find seashells. And I have some cephalopod shells that I found out at Fort Benning. I'll bring some stuff in. I can't figure out for the life of me what I did with my. There's an area in Phoenix City where I found shale. Now, shale is the beginning of oil. You know, first you've got the plants that decompose, and then under the pressure and temperature, they start forming shale, and then the shale will eventually be compressed into oil. But between two shale, you can break it apart, and between two pieces popped open, and you can see the outline of a leaf of a plant, leaf and a very prehistoric flower. So over in Phoenix City, when they found a baby dinosaur feather, and it's actually out 431. We found a CSU, some students from CSU found a baby dinosaur feather. So while this area was ocean, that area was kind of a marshy, mucky, they think. And the Chattahoochee used to be shifted over. And used to be, instead of just a river, it was a meandering, they call it meandering stream, which means it had sandbars in between, and not meandering, braided. So you had waterways kind of coming along like this and braiding, and then land in here. And it looks like the mother dinosaur decided that this was a good place to lay her eggs. And the baby hatched, and it was a feather. And it was such a big find that the National Geographic and the Smithsonian and all these people came down and dug up and found stuff, and we don't know what they found.
Dinosaur feathers, huh?
Dinosaur feather, a baby dinosaur feather. Because they took it to Schwimmer, and they found it, they took it to David Schwimmer, who was probably the foremost in the area on paleontology. And then they sent pictures off to where he went to grad school, and they're going, oh, hell yeah, that's what
Sherman
that is.
is the guy that's at CSU with that big old collection of rocks and stuff.
There are a lot of guys over there that have a lot of that collection, but some of the stuff I found is over there, and I can't get it back.
Yeah, I've seen him. I would talk to him. He's very intelligent when it comes to that.
Oh, yeah.
He could talk for days for it.
Yeah.
He's got books. It's published. All right. Enough of that. Let's do this. But it's, you don't know. I mean, there's so many options right now. We've got all the nuclear stuff going on. We've got seismic activity going on underneath. I don't know if y'all know that underneath Yellowstone there's a caldera, which is the top of an ancient volcano. That's why we have Old Faithful, the geyser, Old Faithful, and all these. Well, there's a lake out there, and the level of the lake is changing. What used to be underwater is coming up, and what used to be above water is going down. That means, what they think that means, is that there's a magma bubble coming up. This area erupts roughly every 260,000 years, and we're past due. If that sucker goes, it's going to split the country in two.
Yeah, Democrats and Republicans.
We won't have to worry about who's a Democrat and who's a Republican. It's going to be that side and this side, with an ocean in between, or an active volcano again.
So if that one erupts, what about the ones that's in like Hawaii and all that? Won't they?
Well, I wonder if that would be such a cataclysmic event that it wouldn't set off the San Andreas fault. There goes California.
Is it true that a volcano can erupt, and if it's like a very calm eruption, the lava can just form new land?
Well, does that, I mean, Hawaii is doing that, that's happening in Hawaii daily. There's a constant lava flow when it hits the ocean, it cools off and builds new land, but it takes a while for it to, I mean, right now it's lava,
Yeah.
cool lava, so. But yeah, that can happen. I mean, there's all sorts of stuff out there that, I don't know if you guys saw the news, there's been a major solar flare.
Recently?
Day before yesterday.
Oh, really?
The sun let loose with one of the biggest solar flares scientists have seen. So
Hate to be flying.
we're gonna be getting some activity from that, believe it or not.
My sister told me that whenever there's a solar flare, anybody who's flying gets a dose of radiation that's like almost unacceptable. So,
I wonder if, due to like carbon monoxide and all of this is what's breaking down the atmosphere. Is it too late to reverse it?
Yeah, it's already out there. I mean, maybe, but I don't think we have the technology.
She said that with no hope whatsoever.
Yeah, basically.
No? Okay.
Good work, Master.
Do what?
It's about to be 22 years, was the best 22 years of my life.
Well, you know, what do the Mayans say?
Man, they say that it's supposed to end in water because they have these hieroglyphics of little gods pouring water down on the planet or whatever. But they said with their calendar ended on 2012, they found another calendar that kind of keeps going. So each time something has happened, even 9/11, it revolves back to a Mayan event, and it just so happened that 2012 is supposed to be the event that says God's coming back or something like that. God's gonna destroy the world or whatever. So,
It's also happens to be the,
Carrie, get me out of here.
Nostradamus also predicted these things. Okay, this is all subtitles. This is after Chernobyl. Yeah, you know there's a recent movie apparently.
Yeah, it's very weird.
Have you seen it?
Sucked. It was about like Scream 4 or
Oh
something.
jeez.
There hasn't been a good scary movie in a while.
I don't know, this one's scary.
I laugh more than anything in those movies.
economy is crashing and burning, these guys were desperate for jobs. And they didn't know. They didn't know what they were getting into. So they're dumping all this stuff, the helicopters are dumping all these materials to try to put the fire out. But underneath, there's a big hole, so it's starting to crash and burn, or starting to collapse. So these guys were sent in, look what they're wearing. To put concrete to reinforce the, underneath the reactor, or where the reactor was.
I mean, would respirators even help? That's what I... So they're all just dead, everybody?
Yep.
Yeah.
I would say all these people that are in this movie are gone.
And they called them bio-robots to dehumanize them because they knew they were just
Who knows?
suicide missions.
Who knows?
I know this is gonna sound like a stupid question, but what do we use nuclear power for?
Right now, France uses it for energy. That's what this plant was supposed to be, an energy plant, electricity.
Whoa.
How you gonna fall out the sky?
Do what?
The radiation made that helicopter fall out of the sky?
No, the guy.
The guy that, the pilot was disoriented from the radiation and he hit it, the giblet of the crane, and went.
You can't just build like a gigantic solar plant that would provide enough energy?
Problem with solar energy is you can't put it on the grid. It's gotta be individual.
I watched a movie where they were taking iodine tablets to counteract.
Mhm.
Is that...
They gave it all to boost up your thyroid production to filter it out.
So you,
Help filter it out.
you could take iodine tablets to help get rid of radiation in your body?
Or to help mediate it, cause you won't get rid of it, but to at least mediate it. That's why they have to watch how many x-rays you get during a year.
Yeah, I was just gonna ask that, why they just wearing lead clothing?
Why are these guys wearing lead clothing?
Why are they not?
Because the government didn't give them lead clothing. The only person wearing lead, you'll notice, I don't know if it's here yet. There was a government official that came to look at it. And to look at the results of the blast. He was wearing a lead apron. But nobody else, the government didn't give him anything else.
After the explosion, the exodus continues.
Now, all these people are leaving the area, but they've already been exposed.
So they're just taking their big dose out into the world with them?
Exactly.
Radius around the plant. 130,000 people are moved, many of whom have already been dangerously contaminated. A 300,000-hectare area straddling the Ukraine and Belarusia is abruptly evacuated and isolated from the rest of the world.
How big is a hectare? I can't reference that.
I'm not sure. I think it's like 3 acres.
3 acres about.
A vast region uprooted, an entire culture ripped from its land, a world wiped out in a few days' time by an invisible enemy.
It was worse than a war. Here you couldn't see the enemy. In a war, you see the cannons, the machine guns, the tanks.
What war is he talking about?
He's just saying in a war.
You see nothing.
World War II is what he's talking about.
The radiation is everywhere. It goes right through you. It gets into you, and you only start feeling the effects later, sometimes years later. It's terrifying.
Meanwhile, the radioactive cloud continues to drift over Europe. It floats over Bavaria and northern Italy. Radioactive cesium-137 and iodine-131 rain down on the south of France and Corsica. Crops and pastures are seriously contaminated. While French authorities deny its presence, the cloud reaches Great Britain and spreads into Greece. In Chernobyl, the level of radioactivity continues to climb. 6,000 tons of sand and boric acid have filled the hole. But underneath this gigantic plug, the white-hot magma continues to smolder. 10 days after the disaster, Gorbachev personally invites Hans Blix, director of the powerful International Atomic Energy Agency, to visit the site. He is the first expert and the first Westerner to visit Chernobyl.
10 days.
Would you still even want to go?
Well, we have seen the site from the air, and we have seen that the little smoke is still coming up from the damaged plant.
There was a brilliant talk about the risk of a second explosion, and I remember that when we were in Moscow, actually we had a friend, a relative of one of my experts, phoned him and said, well, you know, we hear rumors that the second reactor might also explode.
Same kind of thing they were worried about in Japan.
At the bottom of the reactor, 195 tons of nuclear fuel are still burning, giving off incredible heat that is gradually melting the sand. On the surface of the plug, cracks begin to appear.
Once we plugged up the hole, the temperature started to rise. We were afraid because it could have caused another explosion. It was terrifying. Scientists came to take readings. They were very worried. They were afraid the critical temperature would be reached and it would set off a second explosion. That would have been a terrible tragedy.
The cement slab below the reactor core is heating up and in danger of cracking. The magma is threatening to seep through. The water the firemen poured during the first hours of the disaster has pooled below the slab. If the radioactive magma makes contact with the water, it could set off a second explosion even more devastating than the first. The country's top experts are called into action. Vasily Nestorenko was one of them. At the time, he was working on improving the Soviet Union's intercontinental nuclear missiles.
If the heat managed to crack the cement slab, only 1,400 kilograms of uranium and graphite mixture would have needed to hit the water to set off a new explosion.
The ensuing chain reaction could set off an explosion comparable to a gigantic atomic bomb.
Our experts studied the possibility and concluded that the explosion would have had a force of 3 to 5 megatons. Minsk, which is 320 kilometers from Chernobyl, would have been razed, and Europe rendered uninhabitable.
We had to stop the process. If it continued, it would have been an enormous disaster. An
This second explosion would have been accompanied by a terrible shockwave and a massive rise in radioactivity that would have claimed thousands of lives in a matter of hours.
Thank God it didn't happen. There were trains with over 1,000 cars in Minsk, Gomel and Kiev ready to evacuate the population.
The situation is critical. In Moscow, the State Commission decrees 2 emergency measures. First, send in a battalion of firemen to drain the water from under the reactor. They will later be declared national heroes, but will suffer from radiation sickness the rest of their lives. Second, seal the breach more effectively to bring the temperature down once and for all. In 2 days, General Antochkin's men will drop 2,400 tons of lead into the reactor.
When we started dumping lead in, the temperature went down right away. It absorbed well and sealed the hole as it melted, so there was less radiation.
But some of this lead melts when it hits the blaze and vaporizes into the atmosphere. 20 years later, traces of it can be found in the sick children of Chernobyl.
It's highly criticized today, but given the situation, there was no better solution. And all the people, military or civilians, officers or not, worked selflessly. I participated in this first stage, and I can tell you, it had to be done. It was heroism.
During this operation, 600 pilots are fatally contaminated with radiation. All of them will die, but their efforts only buy a few days. Although it has been covered over, the fire still isn't out. Flying over in helicopters isn't solving the problem. They need to get closer, go down into the breach. But how? With the imminent threat of a second explosion still looming, the makeshift measures continue.
Okay, this happened April 26th, and now it's
The
May
blueprints
11th.
of the plant reveal that the active zone can be approached through the cable and pipe tunnels built out of thick cement. A delegation of technicians from the Kirchhoff Institute venture into the labyrinth. It's tough going. Parts of the tunnels have collapsed in the explosion. They pierce through the shell of the 4th reactor with a blowtorch and stick their radioactivity detectors and thermometers in, along with cameras. The result is terrifying. The radiation levels are astronomical, and their worst fears are confirmed. The white-hot magma has cracked the cement slab and seeped into the empty basin.
There was a 5 to 10% risk of explosion. We drained the water from under the reactor, but something absolutely had to be done. Something had to be done underneath the reactor to keep the magma from seeping down.
You guys can, I believe this is the BBC one I was talking about. Let's see what it is. This is the severe days.
Something had to keep it from falling in.
You guys are interested in watching that? And think about it now. You had Japan happen just, what, a year ago? And they're still having the same issues. Lights on. They're still having the same issues. They don't know. Sure. They don't know what to do. They didn't learn from Chernobyl. So, do we really want this in our back door?
Me and my husband are actually going to Japan this year.
Are you?
We want a trip. I'm very nervous.
Well,